Assalamu alaikum everyone, and a very warm welcome to our audience and to another exciting episode of the Knowledge Nexus series 2.0. This is episode 7 and we are thrilled to have you all here for yet another insightful session. In today's episode, we are diving into a crucial and rapidly evolving domain, big data engineering and analytics in AWS cloud. With data becoming the new oil, organizations worldwide are leveraging cloud technologies to manage, analyze, and extract meaningful insights from massive datasets. AWS offers a comprehensive suite of tools and services that enable businesses to harness the power of big data efficiently. To guide us through this fascinating topic, we have an esteemed guest speaker with us today, Muhammad Numan Ali Khan. Our guest speaker is a distinguished expert in cloud computing, big data, and professional education. He is currently serving as the director of the Center for Continuing Professional Education (CCPE) at Surseed University of Engineering and Technology. In addition to being an assistant professor at the software engineering department, he is a trainer, consultant, and academy manager for leading global certifications, including Cisco, AWS, Oracle, EC Council, Alibaba, and Qualcomm. He is also the focal person for SSUET Ignite, Ministry of IT and Telecom, and HEC Coursera 𝗘𝗴𝗶𝘀𝗃 program, making him a leading authority in the field of cloud and big data solutions. It is absolutely an honor to have him with us today. Thank you so much, sir, for joining us today.
Thank you very much. Bismillahirrahmanirrahim. First of all, welcome to the audience. And as Ms. Kashyap already explained a brief regarding me, I'm currently working as Assistant Professor and Director, Center of Continuing Professional Education, Surseed University. And thanks for inviting me by the WIE Society of Surseed University, IEEE Society. And I like to share some information regarding the big data and cloud computing. On this topic, we will learn something, which obviously it is a very wide field, and we can proceed in depth within a complete course of learning with the big data and cloud computing. So, may I start, Ms. Kashyap?
Yes, sir. Yes, sir. Please start your presentation.
Thank you. So now if we start with big data engineering and analytics on AWS, as my introduction is already covered by Ms. Kashyap, you can see that the big data is actually evolving within this decade, or the era is known as big data era. And what is the purpose of big data? Big data is actually driving us towards the data science, that we need to understand the data which we are just generating in lot of bunches. Currently, we are dealing with a huge storm or torrent of the data which is coming across the globe. जो ये एक आपके पास explosion है data की, उसको how we can handle, how we can manage, that is very important. And we want to extract the insight from that data with reference to different actionable outcomes which we want to get to enhance our business and operations and day-to-day working with respect to the data engineering and data analytics. So this is a wide field in which you can see that the data is actually evolving in terms of a unit which we normally do not have to be stored in our devices, like petabytes, exabytes, zettabytes, and yottabytes. So big data, when we use the term, is actually that representation of the data which we are generating on the daily basis, hourly basis, and per minute. If we consider that in the past, we almost the data which is generated till 2010, in 2011 the human mankind generates that data in a single year. Beyond that, which we have digital formation, nowadays we are generating in terms of zettabytes per day of the data. And some companies are managing the data, like Siemens has the petabytes of the data volume on the AWS cloud. And similarly, Itaú Bank has zettabytes of data. The one organization has a lot of that much volume of the data. So big data requirement and demand is evolving day by day. And we can see that the big data is actually driving the insights from that system. and for that we need to get the uh, different kind of mechanisms to be derived through which we can extract the volume of the data. May I proceed to the next slide? Yes. So if you see that we have here, basically I am also a manager of AWS Amazon Web Services Academy. And in SSUET, we offer different courses related to the cloud computing and data engineering. And I am also instructor and trainer of AWS Cloud Computing Solution Architect, DevOps, and uh, data engineering topics. So here we offer different courses. This is just a VLE, virtual learning environment of AWS Academy, in which you can see that different modules, because AWS offer data engineering associate level certification on the cloud, and that training is actually derived for how the humans can handle with reference to the data engineering requirement, which is evolving day by day. So if we see that data scientists, data engineers, and data analysts are working to get the insight of the data and to manage the data which is coming, which is generated at a very large pace, the velocity of the data is very high. And we have to handle that velocity and the veracity of the data. 6 V's, which we will discuss regarding the data in the upcoming slide. We have to manage all those things. We have to process all that data, and we have to get the insight as quickly as possible near to the real time processing requirement of the data. So if we consider that the job roles in the data, as I mentioned, that data engineers, data analysts, and data scientists, all of those job roles are key roles in which the job opportunities are present, and all the organization are seeking these individuals. If you see that the data engineers are actually built all the infrastructure, data infrastructure which is required by the organization. If the multinational company is operating across the globe, so data engineer is responsible to managing the data pipelines and the data warehouses, data lakes, and data meshes, data marts, and all those data fabrics are designed by the data engineers. And on the daily basis, that is managed by the data engineers, and the requirement of the knowledge or a skill set which is required by the data engineer is SQL or no SQL if you are using a RDBMS or relational database, or unstructured key pair value database. Big data technologies which are mostly used by the data engineers is Hadoop, which is open source. And Hadoop, we will discuss a little bit of history of Hadoop. That Hadoop is actually developed in Yahoo, which is the organization, the individual person, open source organization, developed the Hadoop platform, and then the person or the scientist who developed that uh, joined Yahoo in 2006, and then he managed further to develop the Hadoop with Yarn. Yarn is another, yet another, you can say that negotiation or resource negotiator, which mentioned that particular resources on the web of data, that how we can collaborate with different resources, or how we can access those resources in the open source platform. Another technology which is used is Spark for the streaming and for the batch processing purpose on the Hadoop clusters. And Kafka is also used for the IoT and for the real-time systems, for the particular data which is coming in terms of the real-time streaming form. And cloud computing platforms are making the life easy and provide different services to enhance and also provide the support to the open source solution which are widely used on the side of big data, like Hadoop or Spark and Kafka. In AWS, because AWS is the leading cloud service provider, and the 58% of the market share of the cloud is with AWS, and he is the pioneer in the cloud market. So it also offer different services which we will discuss today. Data analyst, another role, job role, which is very important for the big data or data management. In data analyst, you can see that data analyst actually responsible for the analyzing of the data and provides the business insight. When we got the pipeline, when we got the intake or ingestion of the data in the lake or in the warehouse, we want to analyze that data and we want to take the insight, because the top tier or the C level executive persons or members need to analyze the data and get the insight of the data with a particular business growth requirements or to meet the target of sales, marketing, and all those things. So business insight is the responsibility of data analysts, and the requirement is obviously the Power BI tools, business intelligence tools must be familiar, Excel, Tableau, and different skill set is required for the data analyst job. If we go on to the third tier or third job role, which is data scientist. So data scientist is actually required to build the predictive models with the help of machine learning, with the help of AI, with the help of different, you can say, libraries of Python like scikit, TensorFlow, PyTorch. You have to work on those libraries with the Python or specifically for with the R language, which is designed for the data analyst and data scientist to get the machine learning model to be trained over the large volume of data. So statistical modeling, data visualization, and a stock problem solving approach is needed to get these jobs. These are the highly paid job, and almost 300 billion industry is expected till to 2027, which is working on the data side, because all the 500 big fortune companies and other largely highly growing companies are expecting to get the large volume of data, and they want to get the insight and need data scientists and data analysts and data engineers to process and to manage and to give the insight from the data in the real time. So if we see the big data era, because nowadays we are living in the data age, and data is the fuel, as you mentioned in your introduction, that the big data era is evolving as this torrent of big data is data torrent is coming up, and it is combined with the computing source over the cloud. So cloud computing and data management is serving the AI and machine learning to accelerate, which we are seeing here, that artificial intelligence and the machine learning is taking over the world, and at the backbone, or you can say the foundational stone, is lying on the basis of the data and on the core of the cloud computing. So actually this whole big data module is giving you the 6 V's concept, in which we can say that the properties of the data in terms of large volume, the size of the data, as I mentioned earlier, petabyte, zettabyte, exabyte, and velocity, which is the speed in which we are generating a data. As I mentioned that we are generating a lot of data, which actually previously we generate in the year. Nowadays we are generating that volume of the data within an hour or within a minute. As if we consider the normal shares on the Facebooks and the tweets which are going on across the globe, a large volume of data is generated by the humans, by the machines, and by different kind of processes which are ongoing in the industry. So all those things are generating the data. As we are going towards the smart city, smart domestic appliances, all those things are actually generating the data with the help of IoT. So the velocities also increase, complexity is also increased. How the complexity is increased? The variety of the data. As conventionally, if you go in 1980s or 90s, we only have the RDBMS system, relational database management system. We have Microsoft's SQL Server or Oracle, or we have DBase or different kind of Fox Pro, different kind of databases which are relational, and they are working on the normal textual data, which is in form of the you can say record set, and there are primary key or secondary key and the relationships in the data. But when we go on to the current scenario, almost 80% of the data is semi-structured and unstructured. So we have shifted from the structured data to the semi-structured and unstructured data. 80% of the volume of the data is actually coming in the form of the voice, video, images, and different kind of sensors based real-time data inputs or CCTV cameras streaming. So we got that variety of the data which we have to handle, and that generates the complexity. Similarly, veracity, obviously the quality of the data. If you are hearing my voice clearly, you say that the voice is acceptable and the quality is good. Otherwise, obviously the quality also very important for the data which we store in our database. And
Yes.
if we shift, we compress that data, we make a RAR file, we make a compressed file, the quality is affected, and quality must be acceptable to the audience, to the end users. And that is very important when we migrate the data from any source or shift data through the pipeline to the data lake or to the data warehouse for the future use or for the analytics purpose. Then we have the valence, which is the connectedness of the data, the relationships in the data in the form of the joints, in the form of the dependencies. We have to check that. And obviously, the core, the outcome of the big data is the value. We want to get the value which actually enhance the business opportunity and which will generate more revenue, which will generate, give you more insight of the data, and that is the important factor of value. Now if you see this picture, what you observe that this is the open data sets which are available, which machine learning AI uses, and this is the global picture of all the open data sets which are available, and they are actually segregated by different categories. You can see here that different colors are used. Some are representing the linguistic data, some are using the research based data. So these are the data sets, open data set, which are available in the market. And the site I mentioned here, that lodcloud.net, which opened the linked open data sets, and this actually generates the detailed information that you can see the different type or category of the data set which is relevant to the government, which is relevant to the life sciences, geography, social networking, or user generated data, or related to the publications or media, is separated here. So it is very important in terms of the data handling that we have to categorize, we have to classify, we have to represent the data in different data sets, and we have to manage that data accordingly for our data processing or data analytics needs. And obviously, when we categorize the data, like if you are familiar with the W3C standard of RDF, which is resource descriptive framework, so it is actually following that RDF format for the resource description, and all the resources which are actually interconnected, that open data sets are also interconnected with the help of RDF, with the help of HTML and HTTP, and all those links are represented. So this is the global volume of open data sets, or the closed data sets, which are private data sets. Obviously, they are other than these data sets which are openly available. So the different technologies or tools which we normally used for big data platforms. So these platforms, the topmost is Hadoop. So it is actually a distributed storage and processing framework that allows for the processing of large data set across clusters of the commodity hardware. The basically startup, like if you are familiar with the HDFS, which is you can say Hadoop distributed file system, evolved with the Google file system GFS. And the person who is working on HDFS give the name of Hadoop. Hadoop is the toy of his child with the shape of elephant, and he give that name to the that particular cluster. And the batch processing of the large data set is target of the Hadoop. And Hadoop further developed some Hadoop version 1, version 2, with the yarn and with the hive and different hoodie and different kind of flavors you will see in the Hadoop. And all of them are actually dealing different kinds of data. As I mentioned, that graph data is different, textual data is different, voice data is different, video data or streaming data is different. So there are different flavors and different tools which are, because Hadoop is an open source contribution platform and framework, and different kind of tools are available. Spark, which is a fast and general purpose cluster computing system, and it gives you the target of machine learning and graph processing and streaming support in the Spark, and that is very useful for most of the workloads which are dealing with the variety of the data. That batch processing, streaming, machine learning, and graph processing is also done with the help of Spark. Now come to our topic, that is cloud-based platforms actually give the full support to Hadoop and Spark. You can process their data sets, also data volumes which are present in the Hadoop and the Spark, as well as they can provide their own storage also. So if you have their storage, that is completely compatible with their solution, and they will provide the external storage, external clusters, Hadoop clusters, to be supported in the platform. So today our topic is related to the AWS, which is offering different services like Amazon EMR, because MapReduce function is provided by the Hadoop initially, and that Hadoop MapReduce provide both the features, that is processing of the data and data management and resource management also done within the MapReduce in Hadoop 1. And when we go on to the Hadoop 2, they segregate the MR service, MapReduce, with the yarn. So they shifted the responsibilities of clusters management or the resource management separately on the yarn, and MapReduce is doing the work on the data to get the aggregation of the data and to process the data as per need. So from EMR, we do the elastic MapReduce functionality. MapReduce, which is a concept of Hadoop adopted by the Amazon with the help of elastic or scalable options of EMR, which is elastic MapReduce. Similarly, if we go on to the storage site which is provided by the Amazon S3, which is a simple storage service, and in the simple storage service, Amazon provide almost different 8 types of S3s. S3 Glacier, infrequently used, frequently accessed. With the timeline, you can shift, and obviously the tariff is also changed when you shift from one S3 to another S3, because data retrieval time is changed, data freezing time and unfreezing time is changed within a day, within an hour, within a minute. What is the time you need to retrieve the data from the data storage? According to that, the cost varies and the category of the S3 also vary. Then we go on to the Redshift. Redshift is actually a data warehousing solution provided by the AWS, and this warehousing solution, if you compare the database with the warehouse, so basically data base is only dealing with the OLTP systems, online transaction processing system. And if we talk about the warehouses not only taking the online transaction processing systems data or different sources or variety of the data which is coming from different sources and performing the analysis over them with the help of OLAP, online analytical processing. So Redshift is provided the solution of data warehousing in terms of the Amazon solution. And Amazon Athena. Now, Athena is actually, you can say that a complete query engine through which you can extract, you can fetch the data from the data warehouse, from the data lake. Even Athena provide you the service that you can make a query over the compressed data. Like if you have stored a RAR file in your data lake, and for the normal conventional retrieval, if you use a SQL query or you use some MDX query, so what you will get, you have to uncompress the data, and then the query will be run by the database engine. But the Athena provide you the service that instead of decompressing the data, your query will be executed by the Athena engine. And this service is also very powerful for the large volume of data, for the big data, to get the insight, as well as it also provide the columnar data. Now, if the columnar data concept, you have G, can you hear me?
Yes, sir, I can hear you.
Right. So different platforms offer their solution in the cloud domain. You can see here Microsoft Azure, GCP, Google Cloud Platform also provide you the solution related to the big data. And then on the side of the NoSQL, we have MongoDB, we have HBase, we have Cassandra, and all these are NoSQL databases, which are also dealing with the big data platform. Kafka is also giving you the real-time streaming solution over the database, and it is also used for the pipelining of the real-time analytics requirement. Now, if we see that data engineering and data analytics, as our topic is big data engineering and analytics, so engineering, as I told you, that data engineering is to manage the data from the source to the storage through the pipelines. Now, if you are extracting from different sources, so some data is coming from the open source data tier, like we can extract from any open source, or Some data is coming from the sensors, some data is coming from the different kind of devices which are running, smart devices, and some data is coming from repositories or some kind of storages. So we have to ingest all that data within our source, within our you can say that unified data lake or our data warehouse. So that whole task is responsibility of data engineer. So big data engineer is also dealing with heterogeneity of the data. The data is coming from different sources, and all that data is need to be ingest by the data engineer properly, according to the need, according to the pre-processing step, according to the cleaning required, according to any kind of pre-processing required on the data, and then it is served for the analysis purpose to the data analyst. And analysis obviously need to get the questions out of that particular outcome, that when analysis is done, obviously there is some question is in mind for the CEO, for the executives to get the insight of that knowledge. So data engineering drive towards the data product, which is after the analytics is done. So this is the demand of the market, that we need sharp data products which can generate on the fly that insight of the data without spending a lot of time on the large volume of data. So 6 weeks of data, big data are here, that volume, variety, velocity, veracity, and value and variability, which we have discussed earlier also. So if we see that this whole process of data engineering to data science, big data engineering to big data science have 5 steps. If you go on to the first step, which is the acquire data. Acquired data is actually to identify the data source and data sets. So different data sets like Kaggle is very popular data set provider. You have open data from AWS is also available. Different kind of data sets are available. So you want to identify that data sets, retrieve the data, query that data, extract that data as per need. And then you have to, second task is prepare. In the preparing step, you have to explore that data, that what is the spread statistically, what is the quality of the data, and what is the actually distribution, statistical distribution in which the data lies. So you can make the mean, median, mode calculations on the data, and according to that you have to generate the nature of the data, and preliminary analysis is done, that what kind of algorithm you can select. That you if you go on to the ML algorithm, you see that on the basis of the type and category of the data, after pre-processing, you make the selection of the machine learning algorithm, that either I want to use the decision tree or for random forest, or any kind of innovation is required or intuition is required within the existing or how many epochs I will get on the one iteration of the data. So on the basis of that, you have to explore the data, pre-process the data, or pack that data as per need. So unwanted data, the garbage or corrupted data need to be cleaned, and integration of the different sources, like if there are different sources are available, obviously there is a possibility that schema is also differ. So schema of the data is differing, is differ, then you have to make a unified source, unified schema. You have to integrate those schemas together. Like if we talk about the let's suppose star schema, snowflake schema, or galaxy schema, which is used in the data warehouses. Conventionally in the databases, we use the RDBMS based schemas. So fact table and the measures which we want to get from the analytics is designed with the help of pre-processing data. What is the target? On the basis of that, we define the schema, and then go on to the analysis part. So in step 3, we select that actually the algorithm which we want to apply to analyze the data. And when we get that algorithm selection, obviously the target is in mind, that what insight we want to get for after analytics. Like in the data mining approach, we take that analysis part. Like if I say that I will use log normal uh, regression for the purpose of detection of the data insight, so I have to select the particular distribution. Like for the AWGN, additive wide Gaussian noise, we use the Gaussian distribution model to get that. For the wireless system, we use the relay model. relay distribution. So on the basis of that, different kind of data, different types of data, we need to analyze with different probability model, and on the basis of the of that, we select the machine learning and data mining algorithm. Then what we get the result after applying that algorithm, we take the, if we apply the decision tree, we got that yes or no condition on the particular case, particular scenario, either on the medical data. If we take the uh, consideration, the purpose is important, we get the insight, and the final result are to be communicated with the help of visuals, with the help of graphs, with the help of pictorial representation. And this process is iterative process, which is actually running on and on iteratively for the until unless we get the outcome as per need. So this is the Hadoop platform, which you can see. I have to go a little bit quick because we are going out of time. You can see here that HDFS is completely like a different, you can say, tools which are open source tools for different types of data, like Hive, as I mentioned, is used for the pre-processing of the data on the basis of the batch processing, and Graph is used for the node processing, for the graphical data like social networks. Storm is used for the real-time processing. Spark again for the stream based data processing, and so on. So HBase, Cassandra, and MongoDB is specifically NoSQL, which I mentioned earlier, that NoSQL type of data is handled here. So Hadoop gives you this architecture. If we go further, that batch processing and stream processing, different categories are defined here. So this is the detail of MapReduce and Yarn. You can go through in detail of every Hadoop platform, which will give you different type of service. As I mentioned earlier, Hadoop 1 to Hadoop 2, the services are further refined and the performance is enhanced in the system of open source calibration. Now, if we come back to the topic of AWS, if we get the data source which is giving us the seismic data or the textual data or any kind of transactional data, or we got any kind of real data sets, we have to process that data with the help of Athena query. So Athena is the service which take the ingestion of the data, and final what we got, we need to get the insight, and insight with the visualization. So visualization is done with the QuickSight. So this whole process from the ingestion to the outcome through the AWS platform is done with different services. So if we take the difference in OLTP and OLAP, online transaction processing, and OLAP system, this must be understand for the data warehousing to databases concept. So RDBMS to NoSQL to stream is coming under the OLTP, which is online transaction processing system. And when we go on to the OLAP, data lakes and data warehouses are working there to give you the analytics part, and live real-time analytics is done on the side of that processing. Different types of data volume is structured, unstructured, semi-structured. As I already mentioned, currently we are dealing a lot of semi-structured and unstructured data, web logs, social media data, email messages, multimedia contents, graphics, social media posts. All of those are semi-structured and unstructured. While on the structured side, normally we have customer data, financial transaction, and sensor data. So data warehouse and data lakes difference, just to give you the little short perspective, data lakes are mostly popular nowadays because they can handle any kind of data, while data warehouse is restricted for the structured data and semi-structured data, not for the unstructured data, which is not suitable. So if we consider the data lake, so data lake is actually taking the ingestion for log analytics and big data processing and relational databases and all the kind of warehouses for machine learning, live algorithms. So lake is nowadays is very, you can say that central point. And normally we use the term schema on read rather than a schema on write. So what is a schema on read? Basically we in the lake, like we drop the data in the lake without knowing that what is actually the contents, what type of data is this. We ingest that data directly in the lake, and when we go on to the reading process, what we want to kind the outcome, according to that we make a query, and therefore the lake is working on the data schema on read and the schema design with the help of catalog. So if you see that Amazon S3 lake formation, these services are a data lake solution, complete solution, in which we are taking the input for log analytics, big data processing, relational databases, NoSQL, all of them are giving insight of the data in storage. Like here you can see the bucket, which is S3. So S3 is taking all the data, and other services which are in purple color, you can see here, these purposes are designs for the creation of the lake, for the inquiry, or for the searching of any contents in the lake, the Athena, and glue is for integration, for calibration of different varieties and different kind of services with the help of these solution. So S3 to Redshift, and Amazon Redshift obviously give you high performance, but cost is also high. But S3 give you the low cost solution, and data lakes are widely used with the S3, while Redshift is used as a data warehouse solution. So storage cost is increased when you go into the warehouse. Therefore, lakes are widely adopted by the organization. And for the lake, there is no storage limit. In one S3 you can go into the petabytes or zettabytes. So normally in the hard disk we cannot manage this much volume of the data, right? So ETL and ELT process, extract, transform, load process, which is conventionally we use for the schema on write process, and ELT is for the real-time processing, where we need load without wasting any kind of transformational time. We directly load, and after that we perform the transformation. So it will make a more real-time application transaction. Other than that, we have different data sources, third-party data. If we have like Kaggle or open source, we need a data exchange AWS service. If we have the file sharing, then we use a data sync, like mobile, iPhone to Android, or different kind of applications need to share the file. And Flow for the different kind of software as a services, like different services are running on, as like if I give you the example of Chime working with Alexa, or Alexa is collaborating with Chime. So they need to exchange the software base as a service, and they need a Flow on that side. S3, as I mentioned, different kind of S3s are there. So these are listed here: infrequently accessed, one zone, frequently accessed, glacier infrequent. So different kind of S3. The data engineer needs to select them as per need of the organizational data. And this is just to give you the scenario. The banking application data storage also varies from one point to another point, dependent on the type of data. Actually, you have to decide based on the type of data. Aurora is the RDBMS solution by the AWS. Dynamo is NoSQL, like a Firebase or Cosmos DB AWS solution. Redshift is for the data warehouse, and S3 for the user activity logs and error logs. So you have to select that storage, the data storage or database on this type of the data. Like here, if you see that which kind of data you want to storage, individual financial transaction for customers, you need a backup, you need a disaster recovery, you need a complete system. Therefore, you use a reliable solution, Aurora, for the transactional data, which is done by on the financial transactions. Second type, if you see amount of daily financial transaction for data, you transfer that into the warehouse, and for that warehouse you need a Redshift. And this is a volume batch of total amount of daily financial transaction. Like any bank gives the financial transaction to the state bank, it is a complete bulk of the data or batch of the data. So Redshift hold that data as a warehouse. And similarly, third type is user activity logs for fraud analysis. So real-time fraud analysis with the help of ML and AI and different solutions, you need an open search service for that. So that search will extract that what anomaly is going on in the data. Is that anomaly matched with the historical data, or it is a new form of the action is done? Like if you are not using your ATM card at night, and on that transaction the ATM is used on at night at 2 p.m. or sorry 2 a.m., then that is the anomaly. And that anomaly is if open search is running on the actual transaction, it will generate an alarm and detect that fraud or detect the condition. Similarly, other conditions can be applied. Error logs for bank applications is generated in the S3 for the large volume of data. Different kind of glue components which basically make the integration. So ETL jobs integration, data brew, and data quality management, and cataloging. Cataloging is also very important. That why the cataloging is used, it is a very important question. That because you do not know that which kind of data you have put into the lake. When you are extracting the lake, you must know the catalog. That if you go onto any fishing site in the lake, you must know that which kind of fish is present in that lake. According to that, your net, your fishing rod is to be decided. And the catalog provides you the insight that this lake holds the voice data, video data, textual data, which kind of data is actually present in that lake. And similarly, the streaming services for the live, for the real time, like you are currently using a StreamYard, so that is also through with the help of streaming service of the cloud. This is just a solution in depth regarding the kinesis. With the help of real-time system, you got the Athena to acquire, and finally the Kibana or QuickSight can generate the outcome. With the help of the Lambda function, with the serverless architecture, you can implement that solution completely. This is a data lake reasons to generate the increasing operational efficiency, data available, and transactional and capacity of the volume, and then pre-processing steps required for the data volume. EMR, as I told you earlier, for the containerization, for the Kubernetes, for the compute services, EMR support, EC2, and all the outpost services also of AWS. So EMR is very powerful for the cluster infrastructure management. Parallel processing solutions are also drive with the help of the AWS EMR. EMR serverless is also available with the Lambda support. AWS Glue is also available for the pre-processing parallel steps. So EMR is very useful for the map reduce and aggregation of the data which is coming from the data lake, and after that you can take the outcome in the new bucket of S3, which is giving you the curated data or analytical data. So raw data is converted to the schema, and after that you perform the analysis, and then you perform the curation, and with the help of curated data you can perform it at your off peak time, at your downtime, and you can get your outcomes very quickly on the solution. Now thank you very much for the patience and for hearing me.
Thank you so much, sir, for this highly informative session. I'm sure our audience has gained valuable insights into big data engineering and analytics on AWS. Now, we'll have a Q&A session from our audience, and we have a few questions. The very first question that we have is from 𝗘𝗴𝗶𝘀𝗶𝗃, and he's asking, how does batch processing differ from real-time streaming processing?
Right. So, Mr. Shazib, batch processing is like, let's suppose for every bank, they have to report
Hmm.
to State Bank at the end of the day all the
Yeah.
transactions which are done in their branches, and similarly, all the branches are to be, you can say, that restricted to report the daily transaction to
Hmm.
their head offices or to the main branches. This is the batch processing. Like meter reader come to your home and take the data of your meter, and after that the batch is completed for the area, and then the process and meter reading is transferred to the billing department and bills are generated. So that whole process
Okay.
is actually a batch processing. And real time processing, like we are currently doing, that the voice, video, and your text is coming. So this is the streaming, this is a real time
Okay.
processing, and if we store it,
Hmm.
we make it like in the yard or in the Facebook or LinkedIn, all the different pipelines are defined, and on those pipelines we are seeing it live. So actually the data
Hmm.
is generated from one source, and that is streamed on different platforms with their different rates. You can see that
Hmm.
maybe quality, maybe the jitter, maybe different kind of latencies issues are on different platforms. So real time stream processing is different, dependent on the coders which we are using. The quality may differ: sound quality, video quality, voice quality, text quality, all may differ based on the streaming, real time streaming data. And real time streaming is also used in the IoT sensors, in the real time decision making support system. Like if we are doing any tele operations, telesurgery, or any kind of real time operations, like we are operating any robot in the field, so we need a
Hmm.
real time system. Smart cars, like currently we have different kind of Tesla or different automatic cars driving
Hmm.
systems, so they need a real time processing.
Okay. Now, the next question that we have is that what is the role of a data engineer and what are their key responsibilities?
Right. So data engineer, as I mentioned, the three job roles: data
Hmm.
engineer, data scientist, and data analyst. So data
Hmm.
engineer is the first one who has to
Hmm.
face the data, who has to get the data from the sources, who have to ingest the data, who has to design the pipelines to ingest the data, to pre-process, to clean, and to make it available for the analyst. Analyst is the next role. So data engineer is the first one who have to take care of all the data pre-processing steps, all the data sources. You can say that distributed or heterogeneity issues are to be resolved, and the unified single source of truth is to be made by the data engineer, which is the responsibility of the data engineer to ease the life of data analyst.
Okay, now the next question that we have is from Malaika Irfan, and she's asking, if someone in the audience wants to start learning this today, what would be the very first step that you would recommend?
Right. First of all, you must have the clear idea regarding the databases, data warehouses, and data architectures. So
Hmm.
if we talk about, you have the core ideas like I just mentioned you, the Hadoop platform, data, columnar data, row-based data, data
Hmm.
structures which are used in the databases, that RDBMS, how the no SQL key pair value system work, semi-structured data, what type of like JSON file, XML file, different kind of CSVs file. So different kind of data's volumes you must understand. And if you understand that, then you need to integrate them. How I can make a unified source. If I am getting one data in CSV, one in AORV, one in जो है, ORC format, or one in MDB format. So different kind of data formats need to be integrated together. So first of all, you have clear idea of the databases, data types, data handling, how the streaming should come, and then you must have the AWS cloud practitioner, which is the foundational step. That the idea that I use the term Aurora, I use the term
Hmm. Yes.
Dynamo, I use the term of Redshift, I use the term of RDS. So
Hmm.
those basically are the foundational things of the AWS. And then you go on to the data engineering sites, that if you use those foundations and then you build your building or structure over those foundational steps, over those steps, then you go on to the configurational side, that how you can configure a particular service as per need of the operations, as per need of the organization need, and what is the outcome, what is the insight in the minimum time, how you can efficiently develop that solution.
Perfect.
So
Thank you
I
so much,
recommend
sir.
that database courses, and then AWS foundation courses, then database
Hmm.
data engineering associate AWS certification is also
Hmm.
very important to go into the depth of this data engineering topic. So data engineering associate I recommend. After the prerequisite of AWS cloud practitioner and database core, you have the idea of RDBMS and all those things. Thank you.
Okay, okay. Thank you so much, sir. That was
Welcome.
an incredibly insightful session, and a huge thank you to our
Thank
guest
you.
speaker, Muhammad Noman Ali Khan, for sharing his expertise with us today. We truly appreciate your time and the knowledge you have imparted. Sir, I would, if you have any last few words, I would like you to share them.
Right. Before that, I see another question: how do structure and
Yeah,
structure, semi-structured data differ?
differ.
So basically, structured data, if I think you are familiar with the RDBMS concept, that we make a
Hmm.
tables, we make primary keys,
Hmm.
secondary key, foreign keys. So actually what we do, we make a structural format in which we designate a unique identifier, and through which we want to retrieve the data, we want to access the data in the database. So that is a structural format in which all
Yeah.
the contents are stored in tabular structure. Secondly, unstructured, like I mentioned, that voice, video, images, all of those type of data are unstructured data. There is no relationship in one image or one video or one voice directly. You make a correlation analysis, but there is no direct relationship. Like if you capture any image today or after 1 year, you can say that this belongs to one person. But obviously, there is no direct relationship in terms of data content. One pixel is associated with that pixel. You make a machine learning algorithm, but actually, the data content is unstructured. There is no tabular structure present in that. Semi-structured, like I mentioned, JSON file, XML file. So what happens in the JSON, JavaScript object notation? You make the different kind of object-based access, the text file,
Hmm.
but the
Hmm.
objects are containing the attributes, relevant fields. So that is the
Hmm.
semi-structure. Semi-structure is present in the JSON, but the fields are associated with, which are bounded in that structure. So
Okay.
therefore, we called it as semi-structured format. Right. So, lastly, I am thankful to all of you, the team of WIE, or Women in Engineering, and IEEE Society, and hopefully all of you are enjoying your learning process in Associate University of Engineering and Technology, and keep on learning, keep smiling, keep happy, and enjoy your Ramzan, and make your Rodas more fruitful with the learning, not only the the you can say the subjects which are important
Hmm.
for
Hmm.
your
Hmm.
normal growth professionally, but also based on your religious requirement. So this is the month of Quran. Read Quran as much as possible and try to follow the guidelines and instructions of the Quran. Thank you very much.
Thank you so much, sir. Thank you so much again.
Thank you.
And of course, a big thank you to our audience for joining us and engaging with such thought provoking questions. We hope you found today's episode valuable, and I hope you have learned a lot about AWS in our today's webinar. So stay tuned for the next episode of the Knowledge Nexus series, where we'll bring you more industry experts and exciting topics to explore. Until next time, take care, stay curious, and keep learning. Thank you so much, sir, and Allah
Thank you.
Hafiz.
Thank you. Allah Hafiz. Take care.